Hi, I am Dr. Baby Shalini, Associate Professor, Department of ECE, Rohini College of Engineering and Technology. In this lecture video, we are going to see about DC to DC buck converter. So this circuit diagram shows the DC to DC buck converter. So in this, the input voltage Vs is constant DC voltage, whereas the output voltage V0 is a variable DC voltage, and the output voltage is lower than the input voltage. Hence it is given the name DC to DC buck converter. So the important point is, in a buck converter, the output voltage is lower than the input voltage, and it converts the DC voltage, fixed DC voltage, into variable DC voltage. So next let's see the circuit explanation of buck converter. So the capacitor C1 is the input filter capacitor that may be connected to reduce the ripple in the DC input voltage Vs. L and C form an LC filter that connected to reduce the ripple content in the output. And DFW is the freewheeling diode. In place of transistor Q1, we can connect any other power switching devices like MOSFET, JFET or IGBT. Next, let's see about the working of buck converter. So in previous figure, Q1 is the power transistor which is turned on and off by the rectangular pulse applied at its base. So the during the on periods of rectangular pulse, the transistor will be in on condition, and during the off condition of pulse, the transistor is power off. We may connect any other power semiconductor switch in the place of transistor. So DFW is a freewheeling diode, while L and C forms a low pass filter. Vs is the unregulated DC power supply. As we can vary the average output voltage by changing either the duty cycle or frequency, in most of the applications the variation of duty cycle is preferred to variation in frequency. Now the expression for average output voltage in terms of duty cycle is given by V0 is equal to D into Vs, where V0 is the output voltage, D is the duty cycle, and Vs is the input voltage. Here the duty cycle D can be varied between 0 and 1. Therefore, average output voltage V0 will vary between 0 and Vs. As the average output voltage V0 is less than or equal to Vs, this circuit is called as buck converter or a step-down switching regulator. The buck converter is a step-down type switching regulator. The operation of buck converter is divided into two modes. So in mode 1, the transistor Q1 is in on condition. So when Q1 is turned on, the input DC voltage Vs gets connected at the input of the LC filter. The output voltage is held constant by the large value of capacitor. The current through L increases linearly from I1 to I2. The input current flows through transistor Q1 and inductor L and capacitor C, and finally through the load resistance R. So which is shown in the figure 2. Energy is given to the LC filter and the load during this mode of operation. The diode DF is reverse biased and it remains in off condition. Now let's consider case 2 when the transistor Q1 is in off condition. So this mode begins at time t is equal to T1. So when the transistor Q1 is turned off, due to the interruption in current, there is a self-induced voltage which appears across the inductance L. This voltage forward biases the diode DFW and the load current starts flowing through the freewheeling diode DFW. The inductor current continues to flow through L, C and the freewheeling diode as shown in figure 3. The inductor current reduces linearly now from I2 to I1. The output voltage can be varied by varying the duty cycle of the power transistor. The output voltage is now approximately equal to Vout is equal to duty cycle D into Vs. Now let's see the advantages of buck converter. So it needs only one transistor and it is a simple circuit. The circuit efficiency is high and it is more than 90%. The di by dt of the load current is limited by the inductor L. The disadvantages of buck converter are the input current is discontinuous and a smoothing input filter is generally required. It can produce an output voltage of only one polarity. The polarity reversal is not possible. The output current is unidirectional, and finally it needs a separate protection circuit against a possibility of short circuit. Thank you.